Hi everyone, and welcome to our next video on digital logic. In the last video we took a look at finding the sum of products, or SOP, and we did that and we found it and we kept it in the form it was in. In other words, we didn't simplify it. In this video we're going to take a look at simplifying our sum of products. Why would we do that in the real world? Well, whenever we're building any kind of digital circuit, we want it to be cost effective, so we want to use the least amount of gates possible, and we also want to maximize performance, so we want to minimize the amount of gates if we can do that. In this video we're going to take a look at a 3-input truth table and how we can find the sum of products and then simplify that sum of products down to the simplest circuit possible. So I'm going to take a look at this here. If we're going to find the sum of products, step number one tells us that we have to find those outputs that are high. So in this case here, we've got these two outputs here that are high. And if we write the product of the inputs, we would have A times B naught times C. And for this one here, we would have A times B times C. And in step 3, we would find the sum of those products. So output Z would be equal to A B naught C plus A B C. Now, the next step is where we have to use our rules and remember some of the things that we've learned in algebra class. In this example right here, we have A that's common to both, and we have C that's common to both. And what we can do is we can factor that out as follows. We can take out AC, and what that leaves us is B naught plus B. So Z is equal to AC times, well, this is where we can look at our basic identities and recall that if we have something like B naught plus B, which really follows identity 7 here, then B naught plus B is really equal to 1. And using another one of our identities, when we take something like x and multiply by 1, it just comes out to x, and AC times 1 just gives us AC. So what we've done here is we've taken the truth table, which is a 3-input truth table, and really determined that the output in this case really just depends on inputs A and C. And since they are multiplied together, that's an AND gate. So if I was to draw the digital circuit for this, it really just simplifies down to A and C determines what output Z is. And if we looked carefully at the truth table, we would see that that's the case. So in this case here, when A is 1 and C is 1, we get an output that's high. In this example here, when A is 1 and C is 1, then the output's high. So it's really independent of what happens with B. And we see that in this result here. Only inputs A and C really determine what output Z is. That's it for this tutorial. We'll see you next time.